Hi, today we are going to work with logarithmic functions, and you can see that's the graph of the logarithmic function. It has a vertical asymptote along the y-axis, and it runs up along the y-axis but never touches, and then it continues increasing. And this is y equals log, I used base 2 of x. So since you have a vertical asymptote, the domain is x is greater than 0. And since it is continually increasing, we have the range is all real numbers. And in the last section, we were looking at exponential functions. Y equals 2 to the x was one of them. An exponential function has a horizontal asymptote along the x-axis, and we discussed the three important points that the exponential function ran through. With the logarithmic function, this has a vertical asymptote along the y-axis, and it has three important points also. The point 1, 0, it hits the x-axis. We have the point, in this case, 2, 1, because of the base 2, 2, 1, and 1/2, negative 1. And you'll notice that if I look at the points for the exponential function and compare them to the points of the logarithmic function, the x and the y coordinates are reversed. And we've already discussed that when that happens, you have two inverse functions. These are inverses of each other. Now the exponential function has y equals base a to the x. To find an inverse, I switch the x and the y, which I did right here, and then I have to solve for y. So to solve for y, we're going to use the word log. So I'm going to take log base a of x equals y. We'll talk about this relationship in just a minute. But this base a cannot be negative, cannot be 0, and cannot equal 1. That leaves us two options. A is going to be a number between 0 and 1, or a is going to be greater than 1. So when I say find a logarithm, what I'm asking you to find is an exponent. The answer to a log expression is an exponent. So you're really saying, what exponent should I use for base a to get the argument x? So this is the exponential form of a function. And if I want to change the exponential form to logarithmic form, I just say base to the exponent equals the argument. So base is a, and that goes in the base position. Exponent is the answer, equals the argument. And the argument is what the log base a is working on. So let's say I want to solve this logarithm. So I'm really solving for an exponent. So base to the exponent equals the argument. And I would say, okay, 4 squared equals 16, so x equals 2. We'll do another one. Base to the exponent equals the argument. And you could see the exponent would have to be 3. And the x could be anywhere in a logarithmic expression. So base to the exponent equals the argument. And then looking at it in this form, I could tell that x is 5. Over here, I might ask you to find the argument. So base to the exponent equals the argument. And you could just put that right in your calculator and you would get 1/7 as the answer. So now you'll have to find the domain of a logarithmic function. So let's take a look at this first example. The argument must always be positive. That is your restriction. So take that argument and set it greater than 0. In this nice linear expression, I'll just add 2 to both sides, and x is greater than 2 would be my domain. But the argument can sometimes be nasty. So take that argument and set it greater than 0. Since this is a rational function, it's not just some simple linear expression. Just type that into your calculator And you want to see from a previous section, where is this function above the x-axis? And I can see it's above the x-axis from -infinity to -3, and it's also above the x-axis on this piece from 1 on to infinity. Certain characteristics of logarithmic functions. So if the base is greater than 1, your logarithmic function is going to look like this. It's going to be an increasing function. The domain is greater than 0. The range is all real numbers. Notice it passes through the point 1, 0. The same thing is true if the base is a fraction between 0 and 1. In this case, however, it's a decreasing function. So those are the differences. When a is greater than 1, the log graph is increasing. When a is between 0 and 1, the graph of the log is decreasing. Now, the natural log function. If you ever have a log base e, well, remember, e is approximately 2.718. It's Euler's number. We don't write it as log base e. We write it as ln, the natural log. In French, it's logarithmic naturel. But ln of x. And you find the ln button on your calculator on the left-hand side. So you can graph y equals ln of x, and you can see you have an increasing function because e is a base bigger than 1. Another important logarithm is called the common logarithm, and that's when the base is 10. If the base is 10, you won't see the 10 written at all. It's just assumed to be a base 10. You also have that button on your calculator. So you'll have to solve logarithmic equations. Don't solve it in log form. Always take it to exponential form. Base to the exponent equals the argument. And then you can work it out. 2 cubed is 8. Subtract 1 from both sides and divide by 2. For this equation, base to the exponent equals the argument. And then you can see x is 7. 7 cubed is 343. You'll have equations with base e. Now, in order to solve that, you are not allowed to have any coefficients in front of e. You're not allowed to have any multiple factors there. So you're going to divide by the 2. Then, to get rid of an e, to undo, we use its inverse. The inverse of e is ln, natural log. So I'm going to natural log both sides. The ln will cancel the e out and the 3x drops down. Then divide by 3. Now in my Labs Plus problem, you have f of x equals log base a of x. And they tell you the function passes through the point 19, 2. So you have to find a. Pretty easy. You just substitute 19 in for x and 2 in for y. So that gives me this equation. And then I don't want to solve it in log form. I'm going to say base to the exponent equals the argument. And then to solve this, I'll just take the square root of both sides. Now, normally we would do plus or minus the square root of 19, but remember, the base a cannot be negative, so I'm going to stick with positive square root of 19. And that's it, and I hope you guys have learned a little something.